So this C value and this D value. The C is just like if it was in a parabola. So if you look at that next page right there, if it's a parabola, we're not going to do this page, but if it's in a parabola, we would probably all know that that means we move to the right too. So it's the same thing for sine and cosine. If it's in the parentheses, it's going the opposite direction. So if we have a negative C, that means we move to the right C units. If we have a positive C, that means we move to the left C units. It's the opposite because of that minus sign. So minus C, theta, theta, the opposite of C. So if it's theta minus 2, that's right 2. If it's theta plus 2, that's left 2. With the D, it's on the outside, so it's the same. So a negative D means we move down D units. If we have a positive D, we're going to move up that many units, whatever D is, where D is assigned a number. The A is still where you get the amplitude. Capital A doesn't equal the amplitude. That equals the vertical stretch or shrink because it could be positive or negative. That's what could flip it. But that's where you get the amplitude, which is still always positive. B is still the frequency, which helps you find the period, how far it is from start to finish on these graphs. Yesterday, we always started at 0, and we always finished at the period. Today, that shift is going to be different, so we're not going to start at 0. So if we don't start at 0, we don't end at the period. That distance is the period, but that last value is not the same as the period. So that's what's going to change. Again, we don't really need to talk about that in this section. We'll talk about that a little bit later. All right, so y equals sine theta plus 20 degrees plus 2. Notice in these directions up here, it doesn't tell you degrees or radians. Whenever there's a horizontal shift, you have to know degrees or radians. Hopefully this one's pretty apparent that we're in degrees because we see that degree symbol. If I took that degree symbol away, now it becomes radians. Just because there's not a pi doesn't mean not radians. Degree symbol means degrees. No degree symbol means radians. Now, if there's a pi, is it in radians? Yes. But if there's not a pi, it's still in radians. Okay? The degree symbol is what makes it degrees. And that is only going to be affected when we do our period and our horizontal shift. So first thing, amplitude. So the amplitude is 1 because we're at y equals a sine b theta minus c plus d. We're just using that general formula. The period, we look at c to determine our period. Yesterday c was 0. There was nothing there, so that's why you had to be told. Today there's something there, so you have to figure it out. Never will you get to pick which one you like the best. You'll either be told or you have to use the correct one. You don't get to pick. So the period is 360 degrees over B. B is the number right here, which is 1. Now you have to be a little bit careful because notice here that the B value is not inside the parentheses. So if I had something like y equals 3 sine 2 theta minus 6, let's say I had that. B still equals 2. But now C is not 6. We would have to say 3 sine. We would have to factor that 2 out and make it look like that. Now that doesn't happen very often, but you have to be careful because every once in a while that happens. Now if the B, yesterday the B was just attached, which is no big deal. If there's no C value, it doesn't matter. Now sometimes you might see this. There might be an extra parenthesis there. That's no different. This is still B. This is still theta minus C. It's when the 2 is connected with the C value right there, you have to factor it out. Okay?
Will we ever have an instance where you can't factor out?
You can always factor out. Might not be pretty, but you can always factor out.
Okay.
So like, if we change this to 2 minus 5, we can still factor out a 2. It's just not pretty, right? So now it's a fraction or a decimal. So you can always factor. It's just not always a nice number. Okay. All right, so the period is 360 degrees. Now, yesterday, we could start graphing, but we can't start graphing yet. We still have to figure out our horizontal and vertical shift. So this is where you can think of it two different ways. We can write what C equals, or we can say what we're doing. I'm going to show you both ways. You have to know both ways, but you pick which one makes more sense to you. Now, if we use this, theta, now the B is in the same place. There's a theta. This is minus, this is plus. So C does not equal plus 20, it equals the opposite. C is equal to negative 20 degrees. The C value is the opposite of what's in there. Or we could say it in words. We could say we're moving left 20 degrees. We are not moving left negative 20 degrees. The left takes care of the sign, the minus sign. Okay, just like you don't say, I dropped a ball negative 3 feet. Okay, the ball going down 3 feet or dropping takes care of the negative. You don't say dropping negative 3 feet. So C equals negative 20 degrees or left 20 degrees. Now, one thing you'll start to realize is the C value and the period are always going to be like terms. If they're not like terms, you've done something wrong. So if there's a degree symbol, keep that degree symbol. Don't drop it, because if you drop it here, then you're going to drop it here, and then you get all kind of points taken off for not having a degree symbol. The period and the C value will always be like terms, always. They'll either have a degree symbol, they won't, or they'll have a pi. Those are the three options. Yes?
Oh, can the pi's ever cancel out between the period and the
Yes.
They can? Okay.
Just like yesterday. All right, and then D is the same, so D is equal to 2, or we can say our graph is going to move up 2.
Wait, why are you're not going up 20? You're not going up 2 degrees though.
Nope.
No?
Y is not, and Y will never have a degree symbol. Y only is a value. The only place there can be a degree or a radian is the x-axis. And that goes back to the unit circle. The unit circle, if we plug in 0 degrees, or if we plug in 0, or if we plug in 90 degrees, or pi over 2, we get a value. The coordinate points are the y values. So the y will always just be a number. The C is the only thing that can have a degree, or a pi, or just be a number, and it's a radian. All right, so now we are ready to graph. Yesterday we always started at 0, but we're not starting at 0. We move to the left 20. So we start at negative 20 degrees. And then we go the distance of the period. So we start at negative 20 and we add 360, which takes us to 340 degrees. Yesterday we started at 0 and we added 360, so that's why this number was the period yesterday. But now we're not starting at 0, so it's not going to always be the end. Sometimes it will still be, but it doesn't have to be. Now we have to find the midpoint. Halfway, so we add and divide by 2. So negative 20 plus 340 is 320. 320 divided by 2 is 160 degrees. Negative 20 plus 160 is 140. Divided by 2, 70 degrees. 160 plus 340, 500. Divided by 2, 250. Now, there's another way to do that too. If we look at this, there are 1, 2, 3, 4 equal sections, right? So those are all the same distance apart. So this distance is 360. There's 4 equal sections in 360 degrees. So how far is each section?
90.
We take the period, divide it by 4. You could do negative 20 plus 90, plus 90, plus 90, plus 90. You could do it that way also. This number isn't always nice with a dividing by 4. Sometimes it is, but if that way makes more sense to you, then do it that way. How you come up with those values is up to you. Now, the y-axis. The y-axis always happens at x equals 0, in this case 0 degrees. So the y-axis isn't going to happen at negative 20 ever. So the next thing is to put the y-axis in the correct place. The correct place would be at 0, which is somewhere between a negative and a positive number. So right now, again, I said this yesterday, but all things, I'm going to grade your x-axis independently of where, I'm going to grade where you put the y-axis. Did you put it in the correct place? Let's say you messed up the x-axis, but according to your x's, you put the y-axis in the correct place. I'm going to grade it off of that, okay? So as long as, now, your x's will be wrong, but your y-axis will be correct. Then yesterday, we just found the amplitude. We went up 1 and down 1. But first, we have to move our graph up 2. So our new middle sinusoidal axis is at 2. So we're up here at 2. I like drawing a dashed line. You don't have to draw that dashed line. I just think it's easier to graph it.
Why is it not 3? Because if your amplitude is originally 1 and then you're going up 2, would you add?
So now our amplitude from the middle goes up 1 and down 1. Do not make your x-axis anything other than 0. Do not say this is 2 and go up to 3 and down to 1. Okay, that is not right. There's nothing right about ever making the x-axis anything other than 0. I don't care how far away you are. I mean, look how close I am to 0 right here. As long as the 1 is above the x-axis, the 2 is above that, and the 3 is above that. Positive numbers are above the x-axis, negative numbers are below. And now we just have to remember our pattern. So sine, we have 3 options. Sine either starts high, middle, or low. It starts in the middle. Be sure you're at your critical values. That y-axis is not a critical value today, so don't put a point on the y-axis. And then, because it's positive sine, it's just like our y equals sine theta, that graph we did yesterday. This is y equals sine theta. It's no different. All that changed was our x and y axis. So we start in the middle. Then we go high, middle, low, middle. You always end where you start. If you do not end where you start, you've done something wrong. If you start in the middle, you're going to end in the middle. You start high, you're going to end high. You start low, you're going to end low. Always start where you end. So notice my graph is not that pretty. This looks a lot bigger, but I am not grading on this distance and this distance. This is not pretty at all. I'm looking, do I have a 1, a 2, and a 3 right there? That's what I'm looking for. Be sure that you do not do something like this and curve it right there. It doesn't curve back down right there. The graph keeps going and then comes down like this. Same thing here. The graph goes low, high. It's going to keep going on and on forever. We're just graphing one cycle right there. And then, just because we moved it left and right, up and down, does not affect the domain. Domain of a sinusoid is still negative infinity to infinity. That has not affected that the graph goes left and right forever. The range is still the low value, which is 1, up to the high value, which is 3. Questions? Okay. All right, cosine. Again, if you need to write y equals a cosine b theta minus c plus d over it every single time right now, do that. I don't require that, but if that helps you, then do that so you can see it over and over and over again. This unit is a lot of repetition. Tomorrow when we do secant and cosecant, you're still going to have to remember the sine and cosine. If you can do sine and cosine, you can do half the unit. When we write equations, when we do the application problems, it's going to be much, much easier for you. So amplitude, we get from the a value, so it's 1. Period equals, we look at the c value. There's no degree symbol and or there's a pi, so that should set us in the direction of radians versus degrees. Yes?
So the C is the period and it's also determining left and right?
No.
Is it 20 degrees?
C determines if we're using degrees or radians, not the period. It's just if we're going to use degrees or radians. C is what helps us determine that. It doesn't determine the period. Nope, it's what, so I see no degree symbol, so I'm going to use radians. So 2 pi over b, b is equal to 1, so my period is just 2 pi. C equals pi, or we can say this moves to the right, pi, whichever one makes more sense to you. Again, you have to know what they both mean, but if I was asking for the transformation, I would accept either one. Either one of those would be fine. Could be a multiple choice question though. List the transformation and it might be listed in words. Or find the C value. It might be listed as a C value. Be sure you know the difference. D is going to be equal to -3, or we can say down 3. We do not say down -3. Down -3 does not make sense. We can say D equals -3, or the description in words for that is down 3. So now we're ready to graph. Now, if I just said graph, you need to know this stuff. Writing it down is helpful, then you don't have to remember it all in your brain, but you might not have to write all that stuff. You might just have to graph it. I might just ask for the transformation, or just the period, or just the amplitude. So write pi, that's where we start. We always start at our C value. And then we add the period. Again, the C value and the period have to be like terms. If this was 2 and this was pi, you did something wrong. So if we add 2 pi to pi, we get correct. Then we find the midpoint. 1 plus 3 pi is 4 pi. Divide it by 2.
2 pi.
Correct. 1 plus 2 is 3. Divided by 2. 3 pi over 2. 2 plus 3 is 5 pi over 2. You like 1.5 pi? That's the same. Decimals and fractions are equal. Now, if it's something like 1/3 pi, and you put 0.3 pi, that's going to be wrong. 0.3 does not equal 1/3. There's no such thing as like 0.3 repeating pi. Don't do that. Fractions will be better in the long run. If you just get used to always writing fractions, it'll be much, much easier for you later on when we do some other stuff. Now, this is pi. It's positive. We all hopefully know that pi is 3.14. So basically this is like 3 right here. So where does 0 go? Well, somewhere behind it. I don't care where, just don't put it on pi. I would say put it somewhat close so it's not too far away and you don't get confused on where your high, middle, and low is. It just can't be on pi. If it's on pi, it's wrong. That's going to be an X. Probably a point. You get at least a point for putting the y-axis in the correct place. If you put it on pi, it's going to be wrong. Then our graph moved down 3, so our middle went down here to -3. Again, I like to put a dashed line. You don't have to. It's up to you. Our amplitude was 1, so from the middle we go up 1 to -2, down 1 to -4.
So, sorry.
Go ahead.
So when you say you go up, you go to -2, and then because you're getting closer to 0.
Well, I just need to go up 1 from -3. So I have to go up and down, the amplitude.
Okay. So it doesn't really matter if it's negative or positive. You're just going up as far as direction or down.
For the amplitude?
Yeah.
Yeah, so if I was at 3, up would be to 4, down would be to 2.
Okay. And then with the negatives, it's just reversed.
Right, so -3 plus 1 is 2, -3 minus 1 is 4. So you're always going up plus and down minus. Always, no matter where it is. Up, however many the amplitude is. All right, so cosine. Does it start high, middle, or low? High. Our y equals cosine theta from yesterday up here, here, here. Looks like that. So cosine is positive, so it stays up high. Our only place to go from high, we have to go middle, then we have to go low, then we have to go middle, then we have to go back high. We started high, we ended high. Be sure you start where you end where you start. Has to be the same place. If you started up high and you ended in the middle or low, you did something wrong. You skipped something. Usually the middle is what gets skipped. Don't skip a middle. Domain, still -infinity to infinity. Range, our low value, which is -4, up to our high value, which is -2. So again, the domain and range for any sinusoid, when it's just a general formula, is negative infinity to infinity. But when we start getting to the application problems, the domain is not necessarily negative infinity to infinity. It'll be the situation that's being represented in the application problem. All right, so on this one, some people don't like that 5 out in front. It bothers them because it's not in the form A cosine or sine B theta minus C plus D. So if you want to move that 5 now, can we do 5 minus 3 before we do anything? No. But what if there was like a plus 6 back here? Could we add the 5 and the 6? Yes, we could add those. Okay, so that's a possibility. But the 5 and the 3 we can't do anything to. But if you don't like that, you don't like that 5 right there and you want to put it over here, go for it. Okay, you can do that. Be careful though, that negative isn't attached to the 5. If we wanted a negative 5, it would say negative 5 minus. Okay, the number behind it, if your answer was negative 5, you wouldn't say 5 minus, you would say negative 5. So the 5 was positive, so we moved it to the back. Again, if you like it in that order, A cosine B theta minus C plus D. Just stays in that order. That looks nicer for you. Our amplitude is always positive. It is not negative 3. The value of capital A is negative 3, but the amplitude is always positive because it is the distance from the sinusoidal up, sinusoidal down to the max and the min. Period. 1/4 theta plus pi. The C value tells us degrees or radians. Now, let's say that was a 3. Are we degrees or radians? Radians. What if it's 3 degrees?
3 degrees.
3 degrees. So that's how you know. You look at the C value, and it will tell you whether to use degrees or radians. But again, you see a pi, that should be like, I know for sure in radians, so the period is 2 pi over B, which is 1/4. We can't divide fractions, so we multiply by the reciprocal, and we get our period to be 8 pi. C is equal to negative pi, or we can state that we are moving left pi. Either one is fine. D is equal to 5, or we can say up 5. Both of those would describe that. All right, so remember, C and the period have to be the same, 8 pi and pi. So if they're not the same, we've done something wrong. If this was, let's say, pi and we just got 8 right here, we did something wrong. Period and the C value must be the same because we start at the C value and then we add the period. So plus 8 is 7 pi. Negative 1 plus 8 is 7. We know it's 4 equal parts, so we can take the period divided by 4, or 7 plus negative 1 is 6, divided by 2 is 3. 3 plus negative 1 is 2, divided by 2 is 1 pi. 10 pi divided by 2, 5 pi. Or if we took 8 pi and divided by 4, we got 2 pi. Negative 1 plus 2 is 1, plus 2, plus 2 pi, plus 2 pi. Either way will work. It's up to you. You don't have to show me. You don't have to tell me which way you like. You can switch it depending on what that number is. It all works. We have a negative and a positive, so our y-axis goes between the negative and the positive. We are moving up 5 for our sinusoidal axis. Our amplitude is 3, so that's up to 8 and down to 2. So I'm going to look. Do you have the 2, the 5, and the 8 labeled? I'm going to look for those numbers. I'm going to look for these 5 numbers. I'm going to look for your y-axis in the correct place. I'm going to look for your 3 numbers here, or do you have those 3 numbers correct? And then I'm going to look at your graph. So cosine. Y equals cosine theta. Again, looking at our parent function, that's our parent function of y equals cosine theta. This is negative. So cosine starts high, but if it's negative, starts low. So at pi, we're going to start low at 2. then our only choice is to go middle, then high, middle, low. So it looks just like this, but it's just flipped upside down. If you can't remember where to start, you can always plug in. This is a little bit more to plug in from yesterday. -3 cosine 1/4 negative pi plus 5. Again, this is if you forgot where to start. You forgot about the pattern. Shelby?
Why does it like end at 7 pi, but the period is 8?
So -1 to 7, that's a distance of 8. If that was pi, it would have been 9, but it's negative pi. Okay. So again, I wasn't sure where to start, so cosine of 1/4 times 0 plus 5. So -3 cosine of 0 is 1. -3 plus 5 is 2. Only if you forgot where to start do you have to do that. You don't remember. I don't know whether to start high, middle, or low. Plug the value in. If you plug that value in, and this ends up something you don't know that's not on the unit circle, then you've done something wrong. All of these numbers will give you either a 2, a 5, or an 8 if they're correct. If they're not correct, then it's not going to give you a 2, a 5, or 8 in this problem. Whatever your high, middle, and low values are, if you plug those values in, it's going to give you a 2, a 5, or 8 if you do it correctly. Domain, -infinity to infinity. Range, bracket 2, comma, 8 bracket. And the last one, again, if you don't like that -2 out front, move it to the back. If you don't care, then leave it there. Just be sure you don't say -2 plus 4. So this one, our amplitude is 4. Our B, C, and D. Period is, there's no degree symbol, or you see this pi, that should tip you off also. We know it's going to be 2 pi over pi over 5. So the question earlier, can the pi's cancel? Absolutely they can, as they will in this one. So our period is just 10. Don't put the pi on it because it's radians. Just 10. Pi divided by pi is 1. C equals 3. Notice our C and our period are like terms. If you put 10 pi here and this was 3, you knew somewhere you did something wrong. Or we can say right 3. We can say D equals -2, or we can say we're going to move down 2. So right 3. So we're going to start at 3, and then we're going to add the period. So from 3, we're going to add 10 to get 13. Don't put 10 at the end. The only ways you could put 10 at the end is if you started at 0. 13 plus 3 is 16 divided by 2. 16 divided by 2 can be simplified, so I expect to see an 8. 8 plus 3 is 11 divided by 2. Can't be simplified. Can it be changed to a decimal? Yes, but decimal and fraction is not, one isn't simplified versus unsimplified. It's just a different form. If you like 5.5 better, put that. But if you mess up and put 6.5, like someone told me earlier, now it's wrong. Now you get an X. 8 and 13, 21 over 2, can't be simplified. You like decimals, put a decimal. It does not matter as long as it's equal. Our y-axis needs to be to the left of the 3. Down 2, so that's our new middle. Amplitude is 4, so from -2 we go up to 2. -2 we go down to -6. Again, how far it is, as long as your -2 is below the x-axis, your +2 is above. I don't care how far. And then your -6 is below the -2. It's sine. Sine starts middle. then I can't remember whether to go high or low. You got to plug in 11 over 2 right there, and you got some math to do. But if I remember, positive sign goes high, then we have to go back to the middle, low, back to middle. So if you remember that pattern, way easier than plugging in 11 over 2 into that problem. I mean, it's not going to be ugly. It'll work out nicely, but it just will save you a lot of work. And then we have our domain again. Domain is negative infinity to infinity. Range would be the low value, negative 6, up to the high value, positive 2.